All right. By request and dedication, many students kind of struggle a little bit with limits and trig. So I'm going to go through a couple examples of how to do trig limits. The most basic trig limits are ones where you're going to use direct substitution. Now, direct substitution is a way of solving limits algebraically, where you identify that the function or that you're using is continuous. So direct substitution, it works for continuous functions. So how do you know if they're continuous? Well, the easiest way to figure out if they're continuous is you simply just take, as x approaches the c value, you simply take that and plug it inside of the limit itself, or inside the function itself. So in this case, what we're going to have is this limit should equal cosecant of 2 pi over 3. Now, you have to know what cosecant of 2 pi over 3 is. This is a basic concept, is like a multiplication of trig. I use little triangles, and I look at pi over 3, that's 60 degrees. Okay, so look at that, 60 degrees, and I'm just kind of demonstrating how I kind of think about this. 60 degrees. It's going to be in the second quadrant because 2/3 is 2/3 of pi is just almost pi, but the second quadrant. So we have 60 degrees, has a ratio of radical 3, 1, and 2. We have a negative right there. How do I know that? Because that's the basic triangle for a 30, 60, 90 triangle. And what we're going to do is we're going to take the cosecant. Cosecant is 1 over sine, all right? And sine is the so, all right? So katoa. So we're going to do, so it's going to be reciprocal of that. So cosecant is going to be hypotenuse over opposite. Okay, so it's going to be reciprocal of that. So in this case, we're going to have hypotenuse, which is 2, over opposite, which is square root of 3. So we know it's going to be 2 square root of 3 over 3. And there's our answer. Okay, we can try another one. Why not? This one right here, you can see that, well, once again, we have the sine of pi x, and we have going to 1/4. Well, looks like a hard trig problem. However, if it is continuous, we can use direct substitution. So we can try sine of pi, plug in the 1/4, and what we essentially have is we're going to take the sine of pi over 4. That is a continuous function. If you have pi over 4 is a ratio of 1 to the 1 to the radical 2. Come on now. That's a 45-degree angle. Pi over 4 is 45 degrees. And so we're going to just look at this and say sine, which is again is so, is going to be opposite, is 1 over the square root of 2. Well, that can be simplified to square root of 2 over 2, and that's our limit. So yes, limits, even though it's the intended height of a function, all right, it's what we're trying to get close to but never really reach, we can solve these using direct substitution if the function is continuous at a given point. So let's try some more. The same thing when you have a problem like this. All right. Let's say we have a limit at secant of pi x, x approaches 3. Well, secant, and we're going to take pi times 3. Well, that's 3 pi. Secant is equal to 1 over cosine. All right. Cosine is the ka. We're going to take 1 over ka, so we're looking at hypotenuse over adjacent. It's a triangle. Well, all right, 3 pi, we go 1 pi, because pi is 180, right? Pi equals 180 degrees. 1 pi, 2 pi's, and 3 pi is going to be located right there. Change that to color. Now, this is not a triangle, so key thing is it's the point of -1, 0 if you have a unit circle. And what we can recall that cosine is x, sine is y, cosine x sine y. So we should have 1 over the x value, which is -1. So our answer is going to be -1. -1. All right. Obviously, if you memorize all these, you don't have to go through this little tricks, but I'm just sharing this with you and how to solve these different ones. And the same thing as if you have 7/6. Once again, cosine is a continuous function, it has pi. Let's just try it out. Cosine of pi, we got the 7/6. All right, cosine of 7/6. Well, over here, just going to box it in so you can kind of see. 7, 6. 7, 6 is going to be over here. Pi over 6 is 30 degrees. We got 1 right equal 3 and 2 is the ratio of a 30, 60, 90 triangle. We're looking for, that's going to be negative, negative. The cosine, which is the ka, and that's going to be negative square root of 3, which is the adjacent leg, 230, and then the 2, so negative square root of 3 over 2. And that should be our values. All right, so this is how you solve basic trig functions. Their direct substitution usually works. It's pretty easy. Plug it in. If it's continuous, you get out a value, and you have your limit. In our next tutorial, I'm going to go through how to solve some more difficult ones.